How to fix ground loop, noise in electrical systems. Have you ever experienced that annoying hum or buzz in your audio system or electrical setup? It might be ground loop noise, a common issue in electrical systems. Let's break down how to tackle this problem effectively. Ground loop noise happens when there are multiple grounding paths between devices. This creates unwanted current flow through the ground conductors, leading to voltage differences that introduce noise. The first step to fixing this is to identify and minimize those multiple ground paths. Make sure that all interconnected equipment shares a single, common ground reference point. Avoid grounding the same equipment at different points connected through various paths. Next, consider implementing a single-point grounding scheme. This means all grounds converge at one central point, which reduces potential differences and prevents circulating currents that cause noise. If a single-point grounding is not possible, you can isolate grounds between devices. Use isolation transformers to break ground loops in audio or signal lines. Optical isolators or differential signal transmission can also prevent direct ground connections. Ground loop isolators designed for audio or video systems are another great option. Proper shielding and cable routing are also essential. Use shielded cables with the shield connected only at one end. This helps prevent ground loop currents from flowing through the shield conductor. Make sure to route cables away from sources of electromagnetic interference, like power lines or transformers. It is also important to check and improve ground connections. Ensure that all grounding conductors have low resistance and are securely connected. Loose or high-resistance ground connections can increase voltage drops and noise susceptibility. Using balanced signal transmission is another effective method. Balanced lines utilize differential signaling, which helps reject common mode noise caused by ground loops. This technique is commonly used in professional audio or instrumentation systems. When dealing with power distribution and protection systems, separate the power ground from the signal ground. The power ground is used for safety and fault current return, while the signal ground is for low-level signals. Connect them at a single point to avoid interference. Designing grounding systems according to standards is also key. Consider cell resistivity, grounding electrode design, and bonding methods to maintain consistent ground potential across the system. Finally, reducing the loop area is crucial. The physical size of the ground loop affects the amount of noise picked up. Minimize the loop area by shortening cable lengths and arranging wiring to reduce loop size. By applying these principles in power distribution and renewable energy systems, you can effectively minimize or eliminate ground loop noise. Proper grounding practices, cable shielding, and isolation methods will not only improve your system's performance but also protect your equipment and personnel.